Welcome to this explainer. Today, we're leaving the familiar rocky terrain of our inner solar system far behind and journeying into a realm that completely defies our traditional understanding of how planets evolve. We are going to meet the gas and ice giants.
Here is our flight plan for today's trip. First, the realm of giants. Second, jewels and ice. Third, moons with hidden oceans. And finally, the cosmic shields. Let's get right into it.
Section 1, the realm of giants, as we leave the inner system.
So, let's talk about the absolute king of planets, Jupiter. Its sheer scale is honestly hard to wrap your head around. It literally contains more than twice the mass of every single other planet in our solar system combined. And because it's so unbelievably massive, its gravity has actually acted like a giant sculptor, actively shaping the architecture of our entire cosmic neighborhood.
And you know that famous Great Red Spot? Well, that perfectly captures just how chaotic Jupiter really is. It isn't just some static landmark painted on the surface. It is a colossal high-pressure storm that's been raging for centuries. We're talking about a vortex so massive you could literally drop the entire Earth inside it and still have room to spare.
Moving right along to Section 2, jewels and ice, venturing even deeper into the outer system.
Now, Saturn instantly grabs our attention, right? It's the jewel of the solar system, famous for those magnificent rings. But here's the crazy part. Those aren't solid bands of light like they might look through a telescope. They are actually dynamic, freezing ecosystems made up of billions of individual fragments of ice and rock, all just in constant, swirling orbit.
So what changes as we keep flying outward? Well, there's a huge chemical contrast between the gas giants and the ice giants. Jupiter and Saturn are your classic gas giants, dominated by swirling hydrogen and helium. But Uranus and Neptune formed way further out, past the solar system's frost line. Beneath their freezing atmospheres, these ice giants are hiding incredibly dense interiors packed with heavier elements like water, ammonia, and methane.
And if you want to understand extreme weather out here in the deep freeze, just look at Neptune. This world boasts the absolute fastest winds we have ever measured anywhere in our cosmic neighborhood. We're talking supersonic gusts whipping by at over 1,200 miles per hour. It makes for one of the most violent environments we know of. Which brings us to Section 3, moons with hidden oceans, the ultimate plot twist in the search for life. Here's where things get really wild. It turns out the moons orbiting these giants might actually be better habitats for life than some actual planets. Take Titan, for instance. It features actual lakes and rivers, except they flow with liquid methane. Then you have Europa, which is likely concealing a massive, liquid water ocean right beneath its icy crust. And Saturn's moon Enceladus? It doesn't even hide it. It literally blasts water-rich geysers from its subsurface seas straight out into the vacuum of space. How incredible is that?
Okay, heading into our final section, the cosmic shields. Let's look at why these giants actually matter to you and me.
Zooming out for a macro view, it turns out these distant, totally hostile worlds are essentially Earth's unsung guardians. As scientists have pointed out, the giant planets protected the inner solar system by influencing the paths of countless asteroids and comets. Basically, their immense gravitational pull acts like a giant cosmic vacuum cleaner, either sweeping up dangerous space debris or just slinging it harmlessly away from the inner planets.
Think about that for a second. Without those giants running interference and deflecting all that orbital debris, Earth would have been hammered by far more catastrophic impacts throughout its history. That protective gravitational sweep provided the billions of years of stability we absolutely needed to, well, exist.
So what should we take away from all this? The outer solar system completely proves that planets come in extraordinary varieties, way more complex than our own rocky neighborhood. These giants have utterly reshaped our understanding of planetary science. And honestly, the most exciting part? They're actively inspiring the next generation of space missions to search for habitable environments.
I want to leave you with this one profound thought to ponder today. If vast hidden oceans really do exist right now beneath the frozen crusts of moons like Europa and Enceladus, could they already contain simple forms of life, just swimming in the dark, waiting to be discovered? It is an absolutely thrilling possibility. Thanks so much for joining me for this explainer. Next time, we're leaving our solar system behind entirely to begin the hunt for distant exoplanets. See you then.